topic of the day is the panel. Very much looking forward to that. It's a bit different than usual, so we have some slides also included into the panel. You will simply see it very soon, which makes also the job for me somewhat easier. Let me just briefly introduce my dear panelists. So we have with us George Touloupas, who is the Senior Director, Technology and Quality at Clean Energy Associates. If you're in EPC development and are sourcing products from China, you will for sure know this company. If not, you will learn more about them now, because you should. We have with us also, again, Stephen Gong, the Senior Product Manager at Cybrid, who just gave his presentation. We are also having with us, very happy to have Joerg Althaus, who is the Global Segment Manager for PV Power Plant Services at TUV Rheinland for many, many years, the face of TUV Rheinland in the solar sector. Joerg, great to have you. And finally, we have Yuan Liu, who's the Senior R&D Director of Ryzen Energy, with Trina, one of the two big proponents of the 210 modules. Yuan is only dialing in via his mobile phone, so we won't see him, but I think that won't change anything. So what are we doing today? So we want to reflect a bit, of course, on what we learned during the conference, and then sort of summarize that under the focus of how to ensure module reliability in times of massive innovation and supply shortage, meaning also that we really take that into consideration. We will focus on 4 topics. And for these 4 topics, which are key for PV module reliability, George and Joerg have prepared a few slides. These are 4 topics. One is backsheets versus glass, encapsulants EVA versus PoE, large module formats, and beyond standard testing. So the first 3 topics will be covered by George, and then Joerg has some slides, and we will always do it this way. They will give a brief introduction, set the scene, and then we discuss it with the panel. So I would simply start with giving the first word to George and present his first slide. George, you want to share your screen and... Please.
So let me...
This is the first slide. Yep. Presentation mode.
Okay. So backsheet versus glass. I think we heard the backsheet side in great detail. But the truth is that in the last few years, we had glass gaining share. I think the main incentive was reliability. So there were monofacial glass projects being developed a few years ago, but with bifacial, it literally exploded. So it's a different world now because it's so much easier. At the same time, it's considered more reliable. That's the general wisdom. But now we have the transparent backsheet products as well. Everybody knows about backsheet troubles. The AAA disaster, PVDF cracking, that's fairly recent. Some PET failures. DuPont has done a great job in collecting field data. So very few materials have a long and solid track record, but that doesn't mean that new ones that cannot have this, right? Because we have so much innovation, as we've seen by both Cybrid and Jollywood. Now, in these questions, the center scene is taken from investors, because they're asking us these questions. So, do we choose glass backsheet or glass? Does location matter? That has to do with, of course, climate, temperature, things like that. Is there a right test? What do you do to test and screen out bad backsheets? When you have severe hail, is it okay to use glass? Because in that case, you have to use 2mm glass, which is half tempered, so it's not as strong as 3.2mm glass, which is fully tempered. And in general, is it a better packaging material than polymers? Is glass better, or polymers can also, good polymers can do the job? How about non-breathability? I saw some questions in the chat about acetic acid formation and rear side PID, the cooling, all this has been more or less touched. So our take is that we've been working on like reliability or studying and consulting reliability for a long time. We don't have a lab, but we're looking at tens of reports every week. We believe that the new IEC technical specification is a good start. It does have a backsheet durability testing sequence. It's not as strict as DPOM's must, of course, but it's a really good start. PVL is also doing that with a bit more of time heat, 1,000 instead of 200 hours. So yeah, careful assessment of project conditions and testing are critical in screening these unsuitable products. Although it's not as easy. You need component testing. The -2 part of the standard is still in the making. So a lot of things, like Gernot said, testing, yeah, and screening by like simple physics and chemistry.
Okay, thanks, George. Yes, thanks for setting the scene. Thanks for setting the scene. You might actually make your mic a little bit louder, so I think you're, if possible. So let's maybe start with Stephen to kind of really take the case for the polymer side and talk about. So when you are confronted with these glass module, glass versus backsheet topic, so what are you seeing actually, or what are your answers to the questions George has actually just pinned down here?
Yeah, I agree with George that really some problems on the modules has been found during this series. Yeah, AAA also people find some PVDFs. It's true that some projects have got some problems, but you know that today I had introduced the trend of a PVDF is developing, because the first generation, second generation, third generation, there are some suppliers already disappeared because their PVDF in terms of fluoride content, from also the performance and also the reliability was not good. So yeah, I also see some modules, but in Cybrid we were working with Akema, with SKC. Also we are doing ourselves PVDF. We had better knowledge than the filmmakers, but they only produce films. They sell into every backsheet laminators. They don't consider too much about backsheet and also modules. So that's why Cybrid modules, Cybrid backsheet selling to market doesn't have any issues. Also, the other point is the customer is choosing the products from supplier. So a customer should also to learn more about the material science, and also do more testing. Yeah, like the presentation showed, testing. Yes, it is better for everyone to find the failures at the laboratory stage. If you put the modules to the outside, the ground installation or roof installation, but you don't know what is the real environment that the module should be put, which kind of aging, which kind of reliability should this kind of module should be used. So if you put bad quality modules to a harsh environment, for sure this module is cracking, is choking, is yellow. Yeah, you cannot say that this is the problem of the material makers. I think mostly it is the case is you choose that you buy a cheap material, you buy a not reliable material. This is the most case, because I was working in module makers some years ago. At that time, we don't know nothing about the backsheet EVA or even junction box or many materials. But what the buyers always buy the cheapest one. They ask the factory to use this kind of material for manufacturing the modules. So what we do, yeah, because you have to do nothing with this kind of actions. What you do is to laminate to modules. Yeah.
Okay.
Yeah, this is from my point of view. Also, yeah, you need to also to look the trend of the material development, because the material can solve the problem of the modules through the better material or higher performance materials. That's why, yeah, many big module players, they choose high-grade material, high-grade EVA. They do a module design, even the mechanical property, yeah, mechanical load.
Okay, let's maybe go to one client. So we have Evan Liu here from Ryzen, one of the biggest module manufacturers. So when you look at backsheet versus glass, Evan, so what's your take at Ryzen?
Hello everyone, this is Evan from Ryzen Energy. From our opinion about the backsheet compared with the glass, I think the market already shows the trend of the what they like about these two materials. I think the backsheet is an organic material, and as you know, the glass is inorganic material. So the reliability is especially we can see for the polymer material, which can be distortion after some years, but for glass, as everyone knows, no distortion even 20 or 40 years. So for the material itself, I think, of course, glass is better. But as you know, PV module only warranty 25 or 30 years. So which means if our polymer backsheet can guarantee 25 years or 30 years, then the product quality is also okay for the PV modules. And if we consider the economic consideration of the total product, I think also the backsheet is also a good consideration. But another one is for the bifacial module. Bifacial module for the transparent backsheet is not so mature. So I think at now for bifacial module, the glass module is still a better choice. But not means the transparent backsheet is not good. Maybe after several years test and which can confirm that transparent backsheet is also quite okay, then maybe the backsheet will come again. But we need to know another which is related with the big size module. For the big size module, as everyone knows, big cell and the big modules will increase the total module size. So for the transparent backsheet module, it's very challenging for this product, because as now for the backsheet modules, for the big modules, we use a support bar at the right side of module. But if we use a transparent backsheet, it will be challenging of the module. Because everyone knows there is a support bar, we need to remove the support bar. So the mechanical loading is a very big challenge. So I think this is the most challenge of the backsheet. But for the backsheet itself, I think the quality should be okay if we design and manufacture very good.
Okay, thanks, Evan. So Jörg, so what are you seeing at TUV Rheinland when you're testing backsheet versus glass products?
Yeah, okay, Michael, thank you. First of all, I want to say that second point that George has on his slide, we see that a lot. I mean, in the last years, we had been involved in many claims from our field inspector portion and technical advisory part of our business, where backsheets have failed, one or the other. And I really like that George points out it's not just AAA. Yeah, PET has failed as well. PVDF has failed. So that's something we're seeing. This is on modules that are fielded, of course. Then, of course, there are things that, you know, somebody comes up with an innovative new product, and such new developments need their starting time, sometimes also fail in the lab. Luckily, now we have a extensive durability test method. In the past, you know, organizations like TUV Rheinland or others would come up with test scenarios, but it was always, you know, one has this, one has that, and it's hardly really meaningful in the end to compare products, because if everybody uses their own test scenario, it's hard to benchmark. That's one thing. Now we see, of course, also the question that George gets is, you know, the investors say, oh, what should I do? Yeah, is it glass? Is it, what do you think about PVTF? What do you think about this or that? Of course, there is not always an easy answer. And if we are honest, also glass, the thin film manufacturers have had extensive experience with glass, and also would tell you a story that glass is not always reliable. Yeah, it also has its issues, glass corrosion or sudden glass breakage due to tempering processes and so on. Nevertheless, I would agree that glass as such, from the material point of view, of course, doesn't leave moisture through, let moisture through. It has a tendency to be more reliable, but it's a question about the application. Where do you need what sort of reliability? And I think one thing you also should keep in mind is the temperature of the modules. If you have glass modules, in some installations, they might run hotter than glass foil modules. So it's a complex topic. I'm not trying to get away from giving a simple answer, but the thing is, there's a lot of new materials out there, and what I would advise is, you know, go through extensive testing, but also include some outdoor exposure. You know, if in the metal industry somebody brings out a new coating, they would make sure to have it tested for more than a year in very harsh environment. And the PV industry tends to bring out new materials with minimal testing times in advance.
Okay, so I think maybe then let's move to the next topic. We don't have too much time, so, and I think we're talking out also now about the other packaging component, encapsulants. Here we have EVA. Shravan has shown that EVA still has a huge market share, but of course we have POE and we have new materials coming also with bifacial. George, please.
Yeah, this is a topic that has been very well researched. I think it's pretty well known actually, and Gernot, I'm a great fan of his, and I learned a lot from his publications and his work. So definitely, yeah, EVA is very well known. Pros and cons. It's low cost, although that is not true at this moment. There is a pretty substantial price increase. Ease of manufacture and cons, because it decomposes, creates acetic acid, which is not great for a lot of things, including corrosion of the conductive parts, like long-term reliability, essentially. Now, POE is overall better because there is also bad POE. Yeah, it can be. There is not one single formulation. These are complex materials. They have additives. They have lots of UV blockers, etc.
A bit louder, George. I think I'm just getting the.
Yeah, there's some problem with the Zoom connection, I think. We have POE gaining, although it's been known for many years, it's gaining a lot of penetration acceptance because of the rear PID of bifacial modules. That's when we started seeing that 3 years ago. Okay, we have to do something, and POE is so much better at blocking the sodium ions moving and destroying the passivation and having huge PID at the rear, right? So that's when it started being adopted. However, and it's a better material all over. However, it used to be a lot costlier than EVA. Now the gap has shrunk. And also it has a lower yield because it shifts. So in the laminator, you have misalignment issues, you have bubble because of that as well. So the module yield drops, and that's an extra cost. It's not only the material cost. That's why we saw suppliers moving from double PoE to EVA at the front, because you don't really need that for PID, and PoE at the back because you need it. Still the same yield problems and the cost, and that's why we have EPE, which looks great. So I think it's gonna be very popular because it does the job. It has the PoE layer to stop the ion migration, and it has good adhesion, good working conditions. But still, the inverters are asking, if PoE is better, why not keep PoE? I mean, what is the price difference? Actually quite small. It's shockingly small, right? I'm talking about material price, not extra cost caused by lower yield. And what is the risk of using mixed materials? Okay? These are not the same material anymore, front and back. And the final question is, it's a really hard one, and it applies to many materials. So if I want modules to last 35 or 40 years, a lot of projects are assuming these timelines, especially in the US. Should I insist in PoE only? And you could ask the same for glass backsheet versus glass. So overall, we see that the PV industry is extremely consensitive to the point of a fraction of a cent. And also that suppliers dislike customization. They might say, okay, I can give you this option, but in practice, it might be, because of timeline deliveries can be super hard, like material shortages. So you can have really high premiums, not really related to the actual cost. So the bottom line is that everything should be successfully screened and tested, appropriate testing. Then if we see the test results that could take several months, yeah, then it should be considered suitable for its designated application. Of course, we cannot answer the question about 30, 40 years because the test we don't really know the connection between testing in a chamber and years achieved in the field. Nobody knows that yet, as of today.
Okay, I think in the end, the answer is always test more, test better. I think we know that also from Corona these days. So Joerg, maybe you want to start first. So what are you seeing when you look PoE and look at EPE, which are now coming more and more in all these different combinations?
Yeah, I mean, I like it. George is saying test. So that's okay. That's our business. But of course, there's, I would say, there are applications. The EVA is still predominantly also in our lab, also for the products being under certification for things to come now. But one thing, of course, we see in particular in Europe, a big move also to develop modules for building integration. And then generally you have other encapsulation materials which already have a good lifespan and good reliability. So in the past, mainly process and existing production lines of large factories and the price, of course, kept large manufacturers to stay away from alternatives to EVA. And we see that at least changing in parts. And I think that's good also for the competition.
Okay. Comments from Evan?
Yeah, I have some comments about the EVA and the PoE. As you know, as everyone knows, several years ago, all PoE module is with EVA encapsulation. The PoE encapsulation is very few, but now, as you know, the dual glass all changed to PoE. Why? Because we consider about the reliability. So not every innovation is to reduce the cost. Of course, we need to guarantee the module's reliability, but not means the EVA reliability is not good, because the EVA usage you already set your 40 years. Also the performance is good, but is the PoE the trend of our module? I think it's not, because why we change the EV to PoE is the backside PID issues of the pack cells. But this PID exactly in the real plant, it won't happen. But if we want to pass the test of the IEC standard, we need to use PoE. That's why the PoE manufacturer changed the EV to PoE. But from the reliability issues, EV I think is still okay. So I think in the future, to consider the reliability and the cost, the trend will be EPE. The EPE will increase the manufacture yield and also the production speed, and also the reliability is also better compared with EV. So I think the EPE will be the trend of the dual glass module. I think for the monofacial modules, the EV plus EPE also a good solution. Okay.
Okay. Stephen, you also want to comment on that?
Yes, you're right. I agree with Ivan because recently is developing for the module solution with material. For sure, the EVA or PE. This is based on different situations. It is getting smaller market share because the double glass PoE high lamination is quite difficult. So that's why people move to EPE. Then people use EVA plus EPE because the P-type perk cells, PID, okay. The problem is the backside. So
there's some
rear side. Yeah. Hello?
Yeah, there's connection issues a little bit, at least.
Yeah, it is an option that to solve the PID or reliability issue, or even the module, where to put the modules, to install the modules. This is my point of view.
Okay, perfect. Okay, then let's, okay, that's fine. Then let's come to the third point, George.
Yeah, this is the toughest. Large format modules, M10 versus G12. So they are gaining market share really quick, although they're fairly new in the city, because they have obvious advantage for balance of system savings with respect to G1 and also M6. M6 is now a transition format. It will be around for years, maybe even for residential, who knows, but definitely the future is M10 and G12. The consensus is that bigger is better for balance system savings. However, we have like two major alliances, the M10, 182 millimeter camp, that accuses the G12 camp of taking excessive risks, mainly stemming from having the bigger sizes, higher current. And we saw Trina's very thorough and really impressive presentation countering exactly these arguments that are coming from a major player from the M10 camp every single week in webinars and presentations. So both camps claim victory of balance of system savings. However, from an analysis that we have performed, we couldn't be conclusive. The data are not really transparent and that are very sensitive to project specifics. There are also price premiums, etc. So I don't think there's a clear winner between M10 and G12 to date, or clear, not in my personal opinion, as it appears to our clients as well. So our clients and investors are asking, what is the best choice, M10 or G12? And are the wide and long variants posing reliability concerns? Will the modules bend more, the cells crack faster, mechanical loads, junction boxes? I think Trina's deck today answered every single one of these quite convincingly, to be honest. And but that needs to be verified by testing and more testing. Yeah. So this is a race towards lower LCOE. And that's not the first time that we've done radical changes or leapt into a gap in a very short time. So we have a much better toolkit now than the older years. Overall, the industry is well way more sophisticated. So the investors should definitely thoroughly check the balance of system savings claims and consider all kinds of contingencies. Some examples, like the mechanical load test must be performed for the specific project tracker rail length and configuration, not taking like a test that has been done on an irrelevant mounting structure. Very important details, because you might have the module completely break down, disintegrate. We've seen lab results like that. Also, the third-party extended reliability test must be completed before the investors commit orders. And the technical advisors must ensure that everything, reports, bombs, bomb lists, check out, everything matches. So not a different bomb order and different bomb tested. So, and also robust quality assurance must be performed, especially for new lines and products that take a long time to ramp up and iron out all the issues and problems. So these are a lot of steps that have to be taken. We need to be very, very careful. And the price will be a lower LCOE.
Thanks, George. Let's start with Ewan, although we know in which direction he will probably argue. Ewan, you want to comment?
Okay, everyone, this is Evan. So from our opinion, I think everyone, I need to post one point. Why or what we do the M10 or G12? As we know, the wafer size from M2, M6, and the M10, and now G12. As everyone knows, big cells will decrease the total manufacturing cost of the wafer and the cells. But M10 or G12 is not the final product. What we choose is the final product is a module. Exactly, the module, the good or not, is not related with the cell itself. So is only the cell size different of the module. So I think what is the best choice? Of course, the no-cost choice, no-cost wafers or cells is better, because we can decrease the totally cost. Of course, G12 is better. And now we're talking about the module, because now everyone knows that the M10 aliens, they said that G12 module is not good. But I think this point is not the right point, because the module, good or not, is based on the design of the module, the structure, the circuit of the inside connection of the cells, and also other design of the products. No, you can't see the G12 module is not good, because G12 module, which can pass all the tests, even we can use the 63209 and the 6331126. Even there is an increased tail test of the new test stand of IC, the 63397. All this increased IC test standard. The G12 and both the M10. I think if you use the right design, right material, all module can be made very good. And so if someone said that one module is not good, I think this is very very not correct point, and this is not a right one to say that. Another one is there is asked question about the reliability of this. If the module size to be changed wider, the module is the mechanical loading will be poor. Is that right? I think if we don't change any design of the module frame and all the glass, yes, it's correct. But if we change the design of the module, the mechanical loading is not a problem. And also for the junking box, if we keep the same material of the junking box and the design, of course there are some issues. But if we change the design, this is not an issue. So I think the one technology of products, good or not, is based on the design. You can't say one product is good or not. You need to check the details of inside. That's my opinion. And also I want to say another opinion. Why somebody now likes the M10, not the G12? Because they have a lot of old capacity of the equipment and the manufacturing capacity. If you want to prolong this capacity of the equipment to be used longer, you must try to pretend the ultimate product to be used for long time, then the capacity can be used more time. But if for the new, as you can see, for the new player of the market of the PV module, they all invest the G12, not M10 or M6, because which have the best LCOE. That's the difference. If you have lower burden of the load capacity, you will use G12. If you have a lot of burden, you will use M10 or M6. This is the logic. Okay.
Okay. Thanks, Evan. So maybe Stephen, one sentence, then Joerg, one sentence, and then Joerg, you can directly start with the final topic when we really talk about beyond the standard testing. Stephen?
Sorry, I maybe lost your point.
Yeah, I think so. Are you? I know. I just wondered. So I think from your perspective as an encapsulation backsheet manufacturer, what's your take on M10 versus G12? But just really in 2 sentences.
Yeah, the story was like this. Before, for M10, last year was a problem of a PET shortage, because the PET is a full width that they cut 1 meter like this, then selling to us, and they relaminate to backsheet. They don't prefer to do the M10 because they waste a certain width of PET and they need to recycle. So they prefer to do G12 because all the 5 meter PET can be selling to all the backsheet makers without any waste. But this year they improved, they changed the line, and now they can do both. They can do M10 and M12. They can do both. For EVA, always no problem, because with EVA we can do 2 meters, 3 meters. So this width can cover every size of modules. No problem from Cybrid.
Okay, perfect. Yeah.
One sentence. Well, I would say about 15, 20 years ago, we already had 8-inch solar cells by a company called Astropower, and now deceased as many. But and also we used to have Gen 8.2 modules of 2 meters 60 by 2 meter 40 by a company called Applied Materials. None of that went so well. I'm not saying this is the same story. I'm just saying new things take their time, and we have to be cautious. But definitely, there's a big movement at the moment.
Okay, super.
Okay, so I'm trying to share my screen, but I think George is still hosting. Okay, thanks. Real quick, going into reliability testing a little bit. A lot of that was said already now. So basically, the story is we have, of course, the qualification standards 1215 and 1730 that are, however, written for mild milder environment. They were never written for a hot climate or a tropical climate or whatever. And originally they didn't incorporate bifacial modules. That was amended beginning of this year. So important to look out when you buy bifacial modules that they adhere to the newest standard. But that's more or less the simple thing. Then since last year, there is a standard or a technical specification out there for higher temperature environment, highly needed. Basically, that standard refers to which kind of tests from the previous mentioned standards should be done at different temperature levels. I will come into that a little bit, and then George already stated in his slides the reliability standard 63209, which of course is again, as any standard, a compromise between trying to do something in a feasible budget, feasible time, but having a long-term meaning. So not an easy task that standardization committees took, I think, 10 years to come up with, but at least it's something now. Looking at the IEC 63126, it basically differentiates also module installation methods on ground mount, roof parallel or roof integrated or insulated basically, and then states a couple of tests that have temperature influences in there. And basically the original requirement for a typical max temperature or 98 percentile of 70 degrees. That's what IEC 61215, 61646, 61730 are okay with. But the question is that true for your site, that 70 degrees, or do you have a risk of running higher? And secondly, of course, if you have roof integration or something like that, then you might look at temperatures going well above that, and you can see that the different standards test methods, hotspot testing or bypass thermal test, thermal cycling, get additions to the temperature, which makes it much more meaningful for the end use. A bit of a wild picture, not going to go into detail. So those of you who have looked at testing know some of those tests, and what I've highlighted here, the reliability test standard basically is taking IEC 61215 requirements and extending them. So instead of doing 200 cycles, you're doing 600 cycles. Instead of 1000 MP, you're doing 2000 MP. But there are other tests that are on top, and one I would like to highlight is the cyclic or dynamic mechanical load test, which is also known as a typical failure for larger modules because it's much higher stress on the modules. So that's something to look out for. And the sequence in the middle with UV and repeating temperature cycles and so on is something that is really good for testing backsheets. This is running several times UV, thermal cycling, humidity freeze, and those backsheets who failed in the field also failed this test miserably. So good points to look out for. As I stated, of course, testing is always a compromise. We don't have that one chamber that has every climate in parallel on the modules. Otherwise, we would have to test for 25 years. So always have to take some compromise. But what the community came up with is what I'm showing here on the right. It's the best match. However, any new design, any new material coming to the market also potentially brings new uncovered relevant design risks. So I can't say this is the method for the next 25 years. Whatever new materials come up, we will have to do a lot of research before as well. Yeah, that's basically all I wanted to share with you for now, but certainly we can discuss some. Go back to that.
Okay, perfect. But I think we are running out of time. So I think I would like to have that set. I would like to rather ask you everyone, and I think you maybe also can, of course, reflect on testing in that final question, everyone. So we're installing this year around 160 gigawatt. Bloomberg New Energy Finance came recently out with their new energy report, and they said in that if we want to go to net zero in 2050, we have to install worldwide in average 632 gigawatt of solar until 2050. So as of now, so it means if we have to go to a completely different scale very, very soon, what has to be taken into consideration most from your perspective when it comes to solar module reliability? Everyone, 2 sentences as the final words. Who wants to start?
Shall I start? Okay. So, I mean, since you just quoted Bloomberg, I would like to quote Bloomberg back. I think it was 2017 in their report where they were saying, don't rely on tier ratings alone, take technical due diligence from a third party into account. And I think that's key, in particular, if we want to go large scale everywhere. There is no off the shelf, go everywhere. The due diligence is key to look and get those massive amount of gigawatts installed right, and don't have miserable failure, because that would backfire on all of us.
Okay. Yeah, George?
Yeah, so my opinion, personal opinion, is that we have to do it. The risks are huge, and just imagine having this discussion of years ahead, talking about perovskites and encapsulation, for example, because they're very good, very cheap, like the lowest LCON, and people want to buy them. So it's gonna get more complicated. And so our duty will be to combine expertise, testing, quality assurance, different evaluation techniques. And it's all about risk mitigation. So there will always be some risk. Let's make it as little as possible. But we cannot wait.
That's okay. Thanks. Evan?
Hello? Yeah.
Yeah.
Sorry, I didn't hear the question.
Okay, so the question was, when we look at completely different dimensions, so Bloomberg has said in order to get net zero by 2050, we would have to install 632 gigawatts solar in average per year. So regarding module reliability, what's the most important thing to do if we want to get to that scale very soon? Two sentences.
Yeah. For the module reliability, I think now for the module become bigger and bigger, I think the most what we need to pay attention is the mechanical loading and the hot spot, and also the if we change new material, we also need to pay attention to the weathering condition test, like the damp heat and semi-cycle. But I think that is not a big problem now, because now the material is being better and better. So, but some of the tests, like such as the hot spot test, and also mechanical loading, this maybe if you're not doing the module good, maybe there are some issues. But I think the good modules can also can pass all the tests. So we need to pay attention to the choosing of the product.
Okay, thanks. Stephen?
Yeah, I agree to all that you have said. My point of view is the module is developing. Also, the material is developing. We have the traditional one that is on the market, and we have the new one will be put it in the market. So, what the so large quantity of the module you need to put outdoor, we need to find based the price and the performance ratio products. This is what we are always looking for. Yeah, from the past till now, and also in the future. Such large quantity of the modules installation for sure need a material to be guaranteed the module safety, hotspot, reliability issues. Yeah, this is what we really need to do. Not only the size of the wafers. This is the power of the module, but the power of the module need to be guaranteed by the polymers. Yeah, this is my point of view.
Okay, thanks. So takeaways. First of all, we have to think big, although a lot of people are telling us. Many analysts have been always too conservative, so industry must think big, otherwise we would have not this silicon shortage that we have at the moment. And at the same time, quality matters. You get what you pay for, and due diligence is important. Just a few words from me as an ending, as a closing for the conference. Minnie, can you just take over and show last slides? As Shravan has said, so I think first so there's the latest reports that we still have for download. If you're interested and haven't downloaded them yet, please go to our website. It's available for free. The upcoming report that we publish is our market survey on backsheets and encapsulation. This will be available end of September. So again, if anyone is interested in advertising, you're welcome. If we are missing anyone, so if Shravan has not mentioned you in his presentation, please get in touch. We will try to get you in. We will also have a couple of more reports and conferences. The next conference that we're having in October will be a first. We are currently working on a market survey on inverters. It's our first inverter survey, and we are focusing on smaller inverters. So that means we look just at the solar rooftop segment, so there will be no central inverters. That's the next conference. So again, if there's anyone interested, please get in touch. That's it from our side. Thanks again to everyone for staying with us. Thanks to the presenters. Thanks a lot to the panelists. Thanks again to the sponsors, and see you soon again in October for the next event. Thanks so much and have a great day or evening. Bye-bye. Ciao.
Thank you. Thank you.
Thank you.
Bye.
Bye-bye.